Hello student, today I will discuss with you the second model paper numericals question. This question directly come in your final board examinations. That's why we will discuss one by one. Now see, first question, it is given that the cell in which the reaction is given 2Fe plus 3 plus 2I minus give Fe plus 2 plus I2, and E naught cell for this reaction is E naught cell is equal to 0.0236 volt at 298 Kelvin. Calculate the value of log Kc, and where log Kc is equilibrium constant. Now see, from next equation, how can we write the answer of this question? How can we write the answer? As we know from next equation, from next equation we can write E cell is equal to E naught cell minus 0.0591 upon n log Kc. This is the value of this is the next equation. Now from this equation we know at equilibrium E cell is equal to 0. At equilibrium E cell value of E cell is equal to 0. Now if E cell is equal to 0, then what happens? E cell is equal to E naught cell minus 0.0591 upon n log Kc. Okay, from here we can write E naught cell is equal to 0.0591 upon n log Kc, and value of log Kc is equal to log Kc. Actually, we have to find the value of log Kc. Now, value of log Kc is equal to E naught cell into n upon 0.0591. That is, and the value of E naught cell as it is given 0.236, and value of n is 2 because 2 electron gain or loss. Value of n will be 2 upon 0.0591. Okay, now this value become, after calculating this value become 2.986. this is the value of log Kc. Okay, value of log Kc is log Kc is equal to 2.986. This will be the final answer. Okay, hope you got that. Now next question it is given Henry constant for the molality of a methane in benzene at 298 Kelvin is 4.27 into 10 to the power 5 mmHg. Calculate the mole fraction of methane in benzene at 298 Kelvin under 760 mmHg. Now how can we calculate? As we know, it is given that आंसर कैसे लिखेंगे? हाउ कैन वी राइट द आंसर? गिवन P is equal to 760 mmHg. P is equal to 760 mmHg, and value of KH is equal to KH value is given 4.27 into 10 to the power 5 mmHg. Now we know very well, according to Henry law, as we know, according to Henry law, we know that P is equal to KH into X. Okay, X is mole fraction of gas. Now we have to find out the calculate mole fraction of methane. Methane is a gas. Mole fraction of here methane. How can we calculate the mole fraction of methane? X methane is equal to P upon KH. This will be the value. Okay, now the value of P is given and KH is given. Simply put the value, get the answer. Okay, so P value of P is 760, and value of KH is 4.27 into 10 to the power 5. Now by simply calculating this, we will get the value 1.78 into 10 to the power minus 3. This is the value of X methane. That is mole fraction of methane. Answer will be 1.78 into 10 to the power minus 7. Okay, hope you got the answer. Now if you see the next question, it is given that calculate the molar conductivity of Cl minus. For like lambda m of Cl minus, we have to calculate molar conductivity of Cl minus ion by using the following data, and the given information is lambda naught for Ca plus 2 is 119 0.07 centimeter square mole inverse, and lambda CaCl2 is equal to 217.67 centimeter square mole inverse. Okay, now how can we calculate? Simply by using the Color's law. How can we write the value of lambda CaCl2? That is lambda naught CaCl2 is equal to how can we write? Lambda naught mu lambda Ca plus 2 plus mu lambda Cl minus. What is the value of mu? Mu is number of coefficient, that is coefficient of individual ion. Here the coefficient of Ca is 1, but coefficient of Cl is 2. That's why how can we write this? Lambda CaCl2 is equal to, here the value of this CaCl2 break into Ca plus 2 plus 2Cl minus. That's why value of mu of Ca is 1 and mu of Cl2 is 2. That's why from here how can we write? 1 into lambda naught Ca plus 2 plus 2 into, for mu for Cl is 2, okay, 2 lambda naught Cl minus. Okay, now from here we have to find the lambda m for molar conductivity of Cl minus. Now how can we write this? For example, if we send this lambda naught Ca plus 2 in this side, what we will get? Lambda naught m CaCl2 minus lambda naught m Ca plus 2 is equal to 2 lambda naught m Cl minus. Okay, now from here as we know this value is given, lambda m naught for CaCl2 and Ca plus 2 is given. By simply putting the value we will get the answer. By putting the value of lambda CaCl2, it is given 271.6 minus lambda Ca plus 2 is 119.0 is equal to 2 into lambda naught m Cl minus. Okay, so here we will go to the value, that is 152.6 is equal to 2 lambda naught m Cl minus. From here lambda naught m Cl minus is equal to 152.6 upon 2. The answer will be 76.3. This will be the answer. In some book it is given wrong answer, because here the value of mu is not considered in some book. Okay, some of the books. The answer of lambda Cl minus will be lambda Cl minus lambda m naught Cl minus is equal to 76.3. That is the correct answer. Okay, hope you got the answer. Now if you see the next question, in next question it is given the calculate the osmotic pressure. Osmotic pressure we have to calculate in Pascal. Osmotic pressure we have to calculate in term of Pascal exerted by a solution dissolving 0.925 gram of polymer of molar mass 1,85,000 and volume is 500 ml water at 37 degrees Celsius. Okay, given value of R is 8.314 into 10 to the power 3 Pascal liter Kelvin inverse mole inverse. Now how can we calculate? Actually what we have given in the question, first we have to write. Now how can we write the answer? Answer, given information is given as it is given. First it is given the weight of solute is equal to 0.925 gram and molar mass, molecular weight given is 1,85,000. This is the molar mass, and another information is volume is 500 ml. 500 ml is equal to, we can write that is 0.5 liter. 500 ml is equal to 0.5 liter. Now how can we, and temperature is given, temperature is 37 degrees Celsius. 37 degrees Celsius in term of Kelvin is 310 Kelvin. Okay, and value of R is equal to 8.314 into 10 to the power 3 Pascal liter Kelvin inverse mole inverse. Okay, now by applying simply the formula of osmotic pressure we can calculate the value of, as we know the osmotic pressure according to colligative properties, pi is equal to CRT, where C is concentration, that is molarity. And how can we write this molarity? Weight upon molecular weight into volume. What is the volume given? The volume is 0.5 liter in term of liter. 0.5 into R. What is the value of R? R is 8.314 into 10 to the power 3, and we know into 10 to the power 3, and T temperature is 310 Kelvin. Okay, now by simply multiplying this, what we will get? The simply put the value of weight is 0.925 0.25 upon molecular weight is 1,85,000. 1,85,000 into 0.5 into R is 8.314 into 10 to the power 3 into temperature is 310 Kelvin. Okay. Now by simply calculating this, by putting the value on calculator, you will get the answer, that is 25.77. This will be the osmotic pressure, 25.77 Pascal. Answer will be 25. Hello student, now next question, if you see, it is given that analyze the given graph drawn between the concentration of reactant in mole per liter versus time in a minute. Calculate the rate of reaction in term of minute and second. How can we calculate? Simply by using the formula of rate of reaction, that is average rate of reaction. We know average rate of reaction is equal to for a reactant we use minus sign, because reactant concentration of reactant decrease with respect to time. That's why for reactant minus delta R upon delta T. We use dr upon dt for instantaneous rate of reaction, delta for average rate of reaction. With interval of time we are using the calculating the rate in interval of time. That's why we use the formula of average rate of reaction. From here, how can we calculate? That is minus from the formula, and final at t is equal to 20, the concentration is at t is equal to 20, concentration is 0.4. And time is equal to final time is 20. Delta R means final concentration minus initial concentration. We are observing from t is equal to 10 to t is equal to 20. At t is equal to 20, concentration is 0.4, and at t is equal to 10, concentration is 0.8. So at t is equal to 20 minus t is equal to 10. Okay. Final time minus initial time, final concentration minus initial concentration. This value become 0. This value become minus 0.4 upon 10, that is 0.4 upon 10, that is 0.04. 0.04, because this time is given in minute. That's why this rate become rate unit is in term of minute, that is 0.04 mole per liter per minute. Now, first answer is this. In term of minute is this. In term of second, what will be the answer in term of second? Or if we convert this minute into second, we divide simply this value by 60. It will minute will convert into 60. Now, in term of second, or in second, 0.04 upon 60. That value become 0.00066. 66, approximately that equal to 6 into 10 to the power minus 4. 6 into 10 to the power minus 4 mole liter inverse second inverse. Okay, hope you got the answer. This in term of second, this in term of minute. Hope you got the answer.